Ever wondered where all the energy in the universe comes from? It's a question that has puzzled scientists and philosophers for centuries. From the smallest atom to the largest galaxy, energy is the driving force behind everything. Not just your drink. That gives you a little boost to get through the day. Or your phone, constantly needing a recharge to keep you connected. But the sunshine, the life-giving rays that warm our planet and power photosynthesis. The electricity, crackling with potential, that lights our homes and fuels our industries. The power that keeps everything running? It's a fundamental question about the very nature of reality. For centuries, we thought energy and matter were totally separate, distinct entities with their own properties. Energy made things happen. It was the force that drove change and movement. Matter was just the stuff things were made of. The solid, tangible substance that occupied space. You could heat, cool, push, or pull matter, alter its state and manipulate its form. But you couldn't turn matter itself into energy. It was seen as an immutable law of the universe that seemed impossible, a fundamental barrier that could not be crossed. The universe, though, is full of surprises. It constantly challenges our assumptions and reveals new wonders. It took a curious mind to realize, a mind willing to question the established order, that matter and energy aren't separate at all. They are intimately connected, two forms of the same underlying reality. Every star, a giant nuclear furnace converting matter into light and heat. Every plant, harnessing the sun's energy to create the building blocks of life. Every muscle movement, powered by the chemical energy stored within our cells, is part of a much bigger story. A story of interconnectedness and transformation. The real breakthrough came, not from incremental improvements, but from a radical shift in perspective. When someone saw the hidden connection, the underlying unity that had been overlooked for so long, between the physical stuff of the universe, the atoms and molecules that make up everything we see, and the energy that animates it, the invisible force that drives all change and activity. Suddenly, the old rules, the long-held assumptions and established dogmas, matter and energy as separate, distinct and independent entities, unchangeable things, fixed and immutable aspects of reality, were shattered. The foundations of classical physics were shaken to their core. The universe became a place, not of static objects and fixed laws, where the impossible was possible. Where matter could become energy, and energy could become matter. The secret, the key to unlocking this profound transformation, a simple, elegant equation, a concise expression of a fundamental truth. That changed everything. It revolutionized our understanding of the universe. It showed that matter and energy, seemingly distinct, are two sides of the same cosmic coin, inseparable and interchangeable. The boundaries between them, once thought to be impenetrable, aren't as solid as we once thought. They are fluid and dynamic, constantly shifting and changing. And that discovery, that moment of profound insight, would unlock the deepest secrets of the universe, revealing the hidden workings of reality. So who found the key? Who was the genius that unlocked this cosmic secret? The key to unlocking the universe's deepest secrets wasn't found in a grand laboratory or a prestigious university. Instead, it was discovered by Albert Einstein, a young patent clerk in 1905, toiling away in relative obscurity. While diligently reviewing inventions and technical schematics, a seemingly mundane task, his mind was constantly churning, grappling with profound questions. He spent his spare time, those precious moments away from the office, reimagining the very fabric of the universe, pondering its mysteries, and challenging conventional wisdom. In his miracle year, as it would later be known, Einstein published a series of groundbreaking papers that would fundamentally transform our understanding of physics, forever altering the course of scientific history. These included his revolutionary theory of special relativity, a concept that challenged long-held beliefs about space and time. Hidden within the complex framework of his work, almost like a secret code, was a revolutionary idea. E equals mc². This profound insight didn't emerge from a single sudden flash of inspiration, like a bolt from the blue. Instead, it was the culmination of years of deep and persistent thinking about the nature of light, motion, the way things move through the universe, and the very essence of reality itself, what it truly means to exist. Einstein came to the groundbreaking realization that the speed of light is an absolute constant, an unyielding benchmark, remaining the same regardless of how you, the observer, are moving relative to it. This seemingly simple yet incredibly profound insight forced him to completely rethink our understanding of space, time, and the relationship between them. It even led him to reconsider the fundamental nature of mass itself, challenging the very definition of matter. He theorized and ultimately proved that mass increases as an object's speed approaches the speed of light, suggesting that mass might not be a fundamental property, but rather a form of energy cleverly disguised as matter. That incredible leap of intuition and rigorous mathematical deduction led to the creation of the most famous equation in all of science. E equals mc², a deceptively simple formula that unlocks the secrets to the immense power of the stars, revealing the processes that fuel their brilliance, and provides a fundamental understanding of the workings of the universe itself, from the smallest particles to the largest galaxies. It was the pivotal moment when matter and energy, once thought to be distinct and separate entities, became forever and inextricably linked, revealing the deep interconnectedness of all things. Let's break down the equation, starting with E for energy. In physics, energy is the capacity to do work, the universal currency for change. It moves, heats, and powers everything from cricket balls to stars. There are many forms: kinetic, potential, chemical, thermal, electrical. Before Einstein, we thought energy could only change forms, never be created or destroyed. This was the law of conservation of energy. But Einstein revealed a hidden vault energy locked inside matter itself. He didn't break the law. He expanded it. The universe's true constant isn't just energy or mass, but there's some mass energy. Under the right conditions, you can turn mass into energy. This was a revolution. Matter itself could be transformed. Suddenly, the universe's energy budget was much bigger than we'd ever imagined. The equation didn't just describe energy, it redefined it, and it changed our understanding of reality forever. Next up, rem for mass. Mass isn't just stuff. It's a measure of how much matter is in something and how much it resists being moved. For centuries, mass seemed permanent and unchangeable. The law of conservation of mass said you couldn't create or destroy it, only rearrange it. But Einstein flipped this idea. Mass is actually a form of energy. Energy that's been frozen into a solid, stable state. Think of it like water turning to ice. Same substance, different form. Mass and energy are interchangeable. The real law is the conservation of mass energy. The total amount stays constant, but it can shift between forms. Even a tiny bit of mass can become a huge amount of energy. The universe's stuff isn't fixed. It can be unleashed as pure power. This insight changed science and our place in the cosmos. Mass and energy are two faces of the same reality. Now let's turn our attention to the wildcard in this equation, c². It's not just c, the speed of light, but c². This seemingly small detail has enormous implications. The speed of light squared, a concept that sounds simple, but holds the key to understanding the sheer power locked within matter. The speed of light, as we know, is the universe's ultimate speed limit. Nothing can travel faster. It's a fundamental constant that governs the cosmos. That's about 300,000 kilometers per second, a mind-boggling velocity that's hard to truly grasp. But in the equation, it's not just the speed of light. It's squared, meaning it's multiplied by itself. This results in a number so astronomically huge, so unfathomably large, it's almost unimaginable. It's a scale that dwarfs our everyday experiences. This incredibly large number is the conversion rate between mass and energy. It dictates just how much energy is released for a given amount of mass. It means that even a seemingly insignificant tiny bit of mass can unleash a colossal, almost incomprehensible amount of energy when converted. Imagine trading just one single dollar for $90 quadrillion, an absolutely absurd amount of wealth. That gives you a sense of the sheer, raw power encapsulated by c². In our everyday lives, we don't typically notice this mass-energy conversion in action. This is because the changes in mass are usually far too minuscule to detect without specialized equipment. But under very special circumstances, like deep inside the cores of stars, or during controlled nuclear reactions in a lab. The effect becomes incredibly dramatic and undeniably apparent. The speed of light squared is the key ingredient, the catalyst, that makes this equation so incredibly powerful and transformative. It's the fundamental reason why the sun shines so brightly, radiating energy across vast distances, and also why atomic bombs possess such a devastating and destructive force. The universe's vast reservoir of energy is, in a way, hidden in plain sight, all around us. It's waiting to be unlocked and unleashed, if the right conditions are met. All of this is thanks to that seemingly simple, yet enormously powerful multiplier, c². That's the underlying secret behind the brilliance and energy of the stars, and indeed the entire cosmos. Put it all together, E equals mc². It's not just a formula, it's a statement about reality. Mass is a volt of energy, and c² is the key. Even a grain of sand, if fully converted, could power a car across a country. Before Einstein, more energy meant more fuel. Now we know matter itself is the ultimate power source, but unlocking this energy isn't easy. Matter is stable. Its energy is locked deep inside atomic nuclei. Only extreme conditions, like those in stars or nuclear reactors, can release it. This equation explains the gentle glow of a star and the violence of a supernova. It's the engine behind the universe's most dramatic events. The power of the cosmos is hidden in every atom, and Einstein showed us how to find it. Want to see E equals mc² in action? Just look at the sun. The sun is a giant nuclear fusion reactor, smashing hydrogen atoms together to make helium. In the process, a tiny bit of mass disappears, converted directly into energy. That energy floods space as sunlight and warmth. Every second, the sun turns millions of tons of matter into pure energy. This process, nuclear fusion, is why life exists on Earth. Every plant, animal, and gust of wind is powered by this mass-to-energy conversion. The sun's steady weight loss keeps our planet alive. E equals mc² isn't just theory. It's the reason you're here. The universe's greatest power plant is shining above you right now. On Earth, we use nuclear fission splitting heavy atoms like uranium. When a uranium atom splits, a tiny bit of mass vanishes, releasing huge energy. This is how nuclear power plants generate electricity and how atomic bombs unleash destruction. In reactors, the process is controlled, turning small amounts of fuel into massive amounts of power. In bombs, it's uncontrolled, releasing energy in an instant. Both rely on E equals mc². The same principle can power cities or destroy them. It's a reminder. Knowledge is powerful, and how we use it matters. Einstein's equation is neutral. It's up to us to choose its purpose. The universe gives us the tools. We decide how to use them. More than a century later, E equals mc² is still at the heart of science. It explains everything from particle collisions at CERN to the birth of the universe. Scientists are racing to build fusion reactors, miniature stars on Earth, for clean, limitless energy. The equation is key to understanding the Big Bang, supernovas, and the most energetic events in the cosmos. But it's also a testament to human curiosity. Einstein wasn't seeking fame or power. He just wanted to understand the universe. His simple question, what if, changed everything. The story of E equals mc² is still unfolding. The universe is full of secrets, waiting for the next curious mind. And that's the real power of Einstein's idea.